this entire house, believe it or not, is actually panelized. So we worked with a Michigan-based SIPs manufacturer. So SIP is structural insulated panel. So the entire house was designed. We laid out all the electrical, where the lighting and outlets go, and then we sent it to the manufacturer, and then we did an approval for panel drawings to completely prefabricate the building. So this includes the walls and the roof. So these walls are actually 6-inch panels. A SIPs panel is basically like a sheet of plywood and then foam and then another sheet of plywood. So it has structural rigidity. And the roof is also SIPs panels. So that's a 12-inch SIP at the top. So in terms of just R value or insulation value for the house, we're about 50% better than code with the walls and the roof for what's required by the current Michigan Energy Code. So on the outside of the SIP panel, I was really trying to achieve a high level of envelope and insulation for the building. So we actually wrapped the 6-inch wall SIP with another 2 inches of foam on the outside of that. So basically these walls are 8-inch thick foam walls. And then there's a strapping layer, so a drainage plane behind the siding, and then the siding. So the whole assembly ends up being about 11 or so inches from drywall to siding. So it's pretty thick, and that's something that really gives us great performance in terms of energy efficiency. What we really want to do is spend a higher percentage of the cost of the project on the envelope of the building. So the walls, the doors, the windows, and then have smaller mechanical systems. That's really behind, that's really part, kind of the foundation of a design like this, is reducing mechanical systems and energy consumption and having a tighter envelope, as we would call it. So the R value is one component, but just as important is the air sealing. So having an envelope that's tight is a really important part of the design as well. So when we were talking about the caulking, I call it the caulking regimen for the project. Whatever the builder planned on doing, I said triple it, because I want to make sure that the envelope is completely sealed. The doors and windows are sealed really well. We use a special expandable foam tape around every door and window for the house that actually is flexible. So a lot of builders will put spray foam around the doors and windows, which is great. On day one or in the first year, it performs really well. But 5 years down the road, once the building is shifting and settling, you get hairline cracks in 40 or 50% of the building. So this expandable foam tape actually moves with the building and keeps it tighter on day one as well as in the future. The other thing you'll notice, which is part of our goals of allowing this building to really have a strong relationship with its natural wooded environment, are all of these deep overhangs that all have cedar soffits. So because the structural insulated panel has its own structural rigidity, we could actually cantilever out with that system and allow ourselves to have these deep overhangs, which on the south side, this is the north side of the building, so we don't have, the overhangs here are really just for entry and for getting in the two doors, right? This is sort of the side door and the front door, but on the south side of the building, those overhangs are really a very low-tech solution for shading the building in the summer when the sun is high in the sky, and we're able to keep about 90% of the direct sunlight out of the building on the hottest day of the year at the hottest time of the day. So we really use that as a design driver for the overhangs. The glass, you'll notice on this side of the building, so basically we have bedrooms upstairs on this side, and we have kitchen, stairway. There's not a lot of glass on this side of the building. We're not really revealing very much about what's going on inside, and that's very intentional. It goes back to the experience of moving through and occupying this building. We really wanted a sense of discovery. So when you move into the building, you really get released to the south side, which is the backyard space. It's very private. The shape of the building, having this 45-degree angle, actually kind of creates a sense of enclosure on the back side, which is where we spend all of our time. We have 3 young kids, a 3-year-old, 9-year-old, and 11-year-old. So we're out, anytime the weather is like this or warmer, we're outside pretty much all day. And the design of this house really promotes that kind of indoor-outdoor living. Okay. The other thing we think about is, from a design perspective for our office, is really thinking about the thresholds of the building. So where you enter, where you exit. You know, every house is going to buy a lot of windows, a lot of doors, but really where you put those doors and windows and the quality of those doors and windows is a much more important decision that really contributes to the long-term success of a project and frankly, the comfort of a project. Yep, the question was if we could choose to use SIP panels again, would we? And the answer is yes, I think we would do it again. There were definitely things about the geometry of this house that made the SIPs a little bit more complicated. But in the end, it's so tight. We have virtually no drafts in this house at all. Between that and the air sealing regimen that we did, it's a very comfortable place to be. So we looked at a lot of passive house strategies for this project as well, which is sort of a German standard. We have the Michigan Energy Code here, but if you go to places in Europe like Germany, you have a passive house building code, which is quite intense. And we really use that as a guideline for us. So we were not able to achieve enough R value for this house, and that was really just a budget issue. In order to achieve a passive house insulation for this house, we would have had to put 4 inches of foam on the outside of the building rather than just 2. But as soon as you go to 4 inches of foam, you get into all these costs with special fasteners to hold the siding on that just didn't work for us. So we did 2. So we got close, but we didn't quite get there for insulation. But we did achieve a passive house level air sealing. So the house does have 0.6 air changes per hour, slightly under. A code-built house in Michigan is, what is it, Bruce, 3? I think it's 3. So that basically means you allow the air to exchange in the house through, you know, gaps and cracks 3 times the volume of the house. And this house is 0.6. So, you know, anytime you're around 1 or less, I mean, it's a very tight house. Why don't we go inside?